Oh, okay. So I think Steven's gonna be back in a few minutes. So I'm just gonna go ahead and start the class while we wait for Steven. So now we've already talked about a little bit about inequalities before, and now we're just gonna keep continuing that chapter a little more in depth. So um, I'm gonna first just start off with this problem. So this is a relatively simple problem. So I'll give you five or 6 minutes, and it's just solving these two inequalities and then figuring out what solutions will work when you actually put these two inequalities together. So I'll give you 5 or 6 minutes on this. Okay, so I think we're going to go over this problem now. I think it's been enough time. So essentially what we have to do, so for the first part, it asks about when x minus 5, hold on, when x plus 2 is greater than or equal to 0. So that would be the second one here. So it would be so this is when it says greater than, but if it was greater than or equal to, then it would be negative anything, -2 and higher, including -2. And then for the second one, which asks about when x minus 5 is greater than or equal to 0, it would be when x is equal to 5 or greater than 5. So those are our two answers for the first two. Then for the second part, since it asks when this will be greater than or equal to 0, that means either both terms have to be positive or both terms have to be negative. So in order for us to figure this out, we can simply look at these two equations, because on this part, it's always positive for both of these equations. On this part, it's always negative. And in these circles, when you multiply them, it'll be 0. So when they're both positive is from 5 and higher. When they're both negative is from -2 and lower. And then we can also include -2 and 5, because if it's -2, this becomes 0, which means the answer will all be 0. And if it's 5, this becomes 0, which means the whole thing will be 0. So that's how we can figure that out. And now there's some notation you also need to learn. This is called interval notation. So what it is since we have two different answers, what we do is we write -infinity, -2. That's the range for our solutions. And then we put a bracket whenever we include that number, and we put a parenthesis whenever we don't. So if this was an open circle, for example, like this, then it would be a parenthesis. And it's just a common thing to always put parentheses for infinity Never put brackets, always put parentheses. And what this union is it's almost kind of like an and symbol. So it's the solution works for this part and this part. So that's what the union stands for, and that's what the brackets stand for. So those are the solutions for this question. So here's another problem again. This one is also very similar. However, this one's a little different in the inequality itself. So try to figure this one out. This one might be a little tricky. So I'll give you 6 or 7 minutes on this. Okay, I've only gotten in one answer so far, so I'm going to give you guys 2 more minutes before I call the end time for this problem. Okay, I think that's enough time for this problem, so I'm going to explain this one now. So knowing the signs for R and R minus A is not enough because even if this is negative, there's no guarantee that it'll actually be less than negative 12 because in the first problem we were comparing it relative to 0, so the signs are all we would need to figure out if it was less than or greater than 0. But in this case, that's not the case. So what we have is we have a factored quadratic because it took out the r. So what we first do is we put it back all together like this, r squared minus 8r plus 12, and then we refactor it this way into binomials because this is easier to work with. So once we do that, we have our 2, so we make those numbered lines again, and recognize here how there's open circles, because these numbers don't count because it needs to be greater than 0, not greater than or equal to. So now that we have these two, we know that we know that it'll have to be between 2 and 6 in order for us to get that negative number. So that's how we can figure out that it has to be between those two numbers, because essentially one of these needs to be positive while the other needs to be negative. So that's when that's when when one of the lines is black, and one of the lines is not black, which will only be this area right here, which would mean there would be opposites, which would make it negative, and that's how we can get our answer for this. So here's another problem with graphing inequalities, quadratic inequalities, and this is where you consider this equality, which is a quadratic. So first find the roots, so the solutions, like what will make this true. Then graph it. If you don't have a graph paper, that's fine. You can just skip it if you can visualize in your head, and then just explain explain why the inequality has no solutions, then reveal what values actually will give you that solution. So since this has 4 parts, I'll give you guys 10 minutes. So at 7:25, we will go over this problem. Okay, we're gonna go over this problem now. So essentially, the easiest way to do this problem actually is by using the quadratic formula, because what you realize very quickly is that this actually has no real solutions. So when you use the quadratic formula, you get this, and then you can factor out the 2, and then you end up getting 3 plus or minus 2i. And when you complete the square, you get x minus 3 squared plus 4. So from this, if you complete the square, and then this is the graph of the equation. And it makes sense there's imaginary numbers because this graph never crosses the x-axis. So it'll never equal y will never equal 0, which is why it only has imaginary solutions. So just as I explained, the graph is entirely above it. So every y coordinate is positive. So because of this, there's no values for x that are real. And then in the previous part, and then by using these roots, which are not real, you know the graph doesn't pass through the x-axis, which means the y-coordinate will never equal 0. So you know it's entirely on one side of the axis, and since it's an upward opening parabola as well. So that's all there was to this problem. Here is another one. This is the last of quadratic inequality we're going to do. So in this graph, we have this inequality. So graph this equation and then figure out what points on the graph will satisfy this inequality, if there's any points, and then figure out if the parabola satisfies the inequality. So I'll give you guys 5 or 6 minutes for this problem again. Okay, we're gonna end this problem right here. So first, we have to graph this inequality, which we do right here. And then the easiest way to do that is by completing the square. And then once we do that, we get this nice parabola here. And then after that, we look back here. It says when y is greater than 2x squared plus 8x minus 3. So the easiest way to figure out if it satisfies that is just plug in a point. So plug in 0, 0, for example, and then that satisfies the equation, which means everything in this part of the parabola is a solution. Everything outside isn't. And in this one, it's kind of hard to see, but the parabola is actually drawn with a dashed line. That's because in the problem it asks for greater than, which means the points on the parabola would not be solutions, because if that was the case, it would have to be greater than and equal to. And then so here's just that said in a different way with a dashed line, and then with this shaded region, and all of this part is the solution for this problem. So that's all there is to that. So now we're going to do a little bit of extensions and harder problems. Excuse me. We're going to do a few harder problems and extensions on what we just learned. So for problem 15.5, solve this inequality and then consider what values of x make each factor in the product positive. This one's a little tough, so I'll give you guys 7 minutes. So at 7:40, we'll go through. Okay, I think we're gonna end this problem right now. So for this problem, it's slightly harder. So the easiest way to do it is write out a whole table like this, and then you'll know when certain things are greater than or equal to 0. So then when you write out your whole table like this, you can figure out when things are negative, when they're positive for the whole range. And then you can figure out this part right here. So then what you essentially see here is that when the only two times it's positive is when it's greater than a half or between -7 and -1. And that's how you can figure out when they're greater than or equal to that. And then here's another way to do it. You write out all of your things like this, and then for it to be greater than 0, all three have to be positive, or two have to be negative. So where the easiest way to see that is when two negatives would be in this area right here, because these two are negative, this is positive, and they're all positive from 1/2 up. And then you can see here again with the notation, we have the U to suggest that this is an answer as well as this, and the parentheses because those points actually aren't part of the solution, but it's everything between those points. So here's another problem. Try to solve this inequality, and remember that you can't divide by 0, and there's a hint here. I'll give you guys 5 problems for 4 minutes for this problem. And also, a lot of you aren't sending your answers in the chat, so when you're done, try to send your answers in the chat so I can keep track of how many people have actually completed the problem. Okay, we're gonna go over this problem now. So, for this problem, so as it says, we can tackle this in a few different ways. But first, we have to factor the denominator. So what we essentially do is we replace this with -1 times 1 minus x, and then that also equals this. So essentially, what we've done is we've kind of rearranged exactly. We essentially rearranged how the inequality is set up by distributing this minus in. But since we multiplied by a negative number, that means we actually have to switch this middle sign here too. So that's what we've done here. And now, since we have this now, we can compare it to 0, and we can consider the signs for all three. But we have to remember that x cannot equal 5 because if we divide by 0, it's undefined. We don't get an actual answer. So, however, x can equal -3 or 1 because if the numerator is 0, your answer is 0. It's not undefined. So we can create another table again like this, and we can figure out when it's positive and when it's negative, and then it's negative during these two parts right here. So that's why our answer we have negative infinity to -3 and 1 to 5. And since it's a less than or equals to sign, that means we have to put brackets around these two parts here. So essentially that's how that works. So here's another problem kind of like that. Try to solve this inequality, and then they give you a few steps to try to help you make it easier for yourself. I'll give you guys 7 or 8 minutes on this problem. Okay, we're gonna go over this problem now. So the first part said move all the terms to one side, so that's what we did here. And then afterwards, we essentially get common denominators, so we can essentially add all this stuff together. And when we do all this math, which you can review later after class if you want to, we get this part right here. And then we can't factor this easily. And then the discriminant, which you learned about, which is the square root of negative b squared over b squared minus 4ac is negative 15, which means all the roots are imaginary. So that means there's no easy way to do this. So then after that, what we have to do is, since we need to figure out how to solve this inequality, we know the numerator will always be positive and the denominator is positive when x minus 2 and x plus 3 are both positive or negative, and they're positive when x is greater than 2 and x is less than negative 3. So which means based on this, our solutions will be this and this. And so now you understand how to do one of those more complex inequality problems. Okay, so here is another problem. This one is a conceptual problem, so it shouldn't take you that long. But I'll give you 4 minutes to think about it, send in your answers. So if x is a real number, must it be true that x squared is greater than or equal to 0? I'll give you 1 or 2 minutes to think about it, and then send in your answer. Okay, this was a relatively easy problem, so I'm just going to explain it. So, essentially, this is always true, and the way you can figure it, and since we're only talking about real numbers in this case, this essentially is always true in that case because if you just think about it, if you graph y equals x squared, it'll always be 0 or positive. That's just how that parabola works, and that fact is what we call the trivial inequality. So this is a very important fact we have, and it helps us solve a lot of quadratic problems. So here is a problem that's kind of related to that previous thing. So try to figure this one out. I'll give you guys 8 or 9 minutes to do it. So give it your best shot. It's kind of a tricky problem. So, and then also send in your answers when you figure Okay, we'll go over this problem now. So essentially in this problem we prove that the sum of any positive real number and its reciprocal must be greater than or equal to 2. So essentially what that means is that x plus 1 over x should be greater than or equal to 2. And so the first way to do this is to work backwards. So what you can do here is you can get rid of the fraction and multiply both sides by x. So you get x squared plus 1 is greater than or equal to 2x. Subtract the 2x over to the other side, and then we know this is always true. So that's how and we know this is true because of that trivial inequality, because if we take this, make x minus 1 squared, we know anything squared is always positive. I mean, at least 0 or greater than or equal to 0. So based on that trivial inequality, we know that's true. And then another way to do it is you can use that trivial property, but we can prove it by saying a squared plus b squared over 2 is greater than or equal to ab. And then essentially for a, we put in x. For b squared, you put in 1 over x. And then with this problem, when you take the 2 over to this side, x plus 1 over x is greater than or equal to 2, and that's what we originally started with. So that's two different ways to solve that problem. I think we have two more problems left for tonight. So this one's kind of tough. These are optimization problems, so these are kind of hard. This one's an easier one. So I want you guys to try and solve it. I'll give you guys again 8 or 9 minutes. Okay, we're gonna go over this problem now. So, this is the equation, I believe, right? Let me check. Yep, this equation is the equation up here. So one very easy way to do this is just graph it, and then you'll know the highest point very easily that way. Another way is to do the complete the square method. So when we do that, we add 24 or 5 to both sides. When you simplify that all down, you get y equals negative x minus 5 over 2 quantity squared minus 3/4. And so based on that, and by trivial equality, we know that this is always non-negative because it's squared, which means the lowest it can be is 0. And due to that, we know that therefore that must mean the highest possible point is negative 3/4. And the reason why is this is negative here. So this is always positive, but since there's a negative, that means this is always 0 or less, which means the biggest this can be is 0, which means y would equal negative 3/4, and that's the highest point. And then that's all there was for that problem, I think. Yep. And this is our final problem. So this one's pretty difficult, I would say, but take your time. I'll give you the rest of the class time to try to do this problem. So take your best shot at it. Okay, I think I actually put up the answer by accident for a little bit, so we're just gonna go over this problem now. So it says if a company sells a video game for $20, they'll sell 10,000 copies of it. For every dollar we raise it, they'll sell 100 fewer copies. So essentially figure out when will you get the highest amount. So this is the price per game in dollars, and this is the number of games sold. So price times quantity will equal your total amount of revenue. So we get this equation here, and the first thing you should do is factor out 100 because it makes the numbers smaller and therefore easier to work with. After that, we complete the square. After we complete the square, we get this whole thing here, and this is what our revenue equals. Now we expand it out, put in the 200, do all the work, get this value here. And we know this is always non-negative, and this expression is maximized at when x equals 40. So therefore, we should maximize the revenue. Therefore, the revenue will get maximized when x equals 40 because since it's negative, that means that's the highest they'll ever get. And that means they should increase the price from $40 to $60. And then back in an earlier problem, it talks about this as well. And then this expression is a factored quadratic because we factored it out. So it's easier to find the roots. And that's essentially it for that problem. If it's still a little confusing, take a look back at you can take a look at it again later when I send out the PowerPoint. So that's all for today. So just another reminder again, a lot of you asked for office hours before, so I'm going to tell you about them again. For those of you in Pacific Daylight Time, it'll be from tomorrow 5 to 6 p.m. And for those of you in China, it'll be from 8 to 9 a.m. This is the link, this is the password. If you have any questions whatsoever on the homework, the challenge problems, or the lecture problems, or any doubts whatsoever, please just stop by and I'll be more than happy to explain it to you. That's all for today. So you guys can hop off the Zoom, and I hope you have a great rest of your evening or day.